Recommendations for electronic circuits prototyping. Use a 30-watt soldering iron to solder a component in Vero board. Use a soldering iron as sponge with water to clean the tip of the soldering iron. Use a good quality soldering wire to wire up your prototypes. Use a proper wire wrapping wire to wire up your prototypes. Use soldering fume extractor to protect yourself from the fumes of the soldering wire. Use a good quality tin-coated Vero board for your prototyping. In previous session, we have used a variable that is ADC channel 0 to read and store the 10-bit result of ADC of PIC16F877A, and we have used a prototype that is variable integer ADC read channel, and we have used this prototype for two channels, that is ADC channel 0 and ADC channel 1, and we have written a command that is ADC channel 0 equals to ADC read 0. In this case, if the voltages on analog channel 0 will be 0, then we'll have the value of ADC channel 0 as 0, and in this case ADC register low and ADC register high will be 0, so we'll have the number 0. And if the voltages at analog input 0 will be 5 volt, then we'll have the number in ADC channel 0 integer, which will be equals to 1023. Here we can find a 10-bit number which is equals to 1023. Now if you would like to read the ADC as 8-bit, then we can declare another variable that is unsigned character ADC channel 0 8-bit, and by rotating right ADC channel 0 2 times, we can move the value of ADC channel 0 to ADC channel 0 8-bit. Here we can see if we rotate ADC channel 0 register 2 times, then we'll have all 8 bits 1 in ADC register low, and if we'll move this variable that is ADC channel 0 in ADC channel 0 8-bit, then we'll have the number which is equals to 255. We'll write a program to convert a 10-bit ADC value into 8-bit ADC value. To convert this raw data from ADC, that is from 0 to 1023, to a meaningful parameter of battery voltages, we can define a variable that is unsigned integer battery voltages. If you would like to read the voltages of a 12-volt battery using PIC16F877A microcontroller from analog channel 0, as we know that the maximum charging voltages for a 12-volt batteries are 14 volts. So we'll convert the maximum voltages, that is 15 volt, into 5 volt. As we know that the maximum reference voltage for analog channel 0 is 5 volt. We'll use an operation amplifier circuit, that is a difference amplifier, to convert these 15 volts into 5 volt. As you know that the output of a differential amplifier equals to minus times R2 divided by R1, V1 minus V2. So if we'll select the value of R1 as 15K and R2 as 5K, and by placing these values into the formula of differential amplifier, we'll get the result that if the difference between these two voltages, that is V1 and V2, will be 15 volt, then we'll have the output of the amplifier as 5 volt, and it will be equals to 1023 as digital number. So we can say that if the voltages will be 15 volt, then we'll have the equivalent digital number, that is 1023. Now how to convert this number, that is 1023, into 15 volt? We'll use a formula. We'll divide 1023 by 15, so we'll get 68.2. Now we can move the value of ADC channel 0 after dividing it by 68.2 to the battery voltage variable. We can display the result of battery voltages as 0.0 to 15.0, which requires only 3 digits, and we can define the variable as character instead of integer. Now we'll start writing a program to convert this 10-bit ADC value into 8-bit ADC value, and we'll also convert this raw data into battery voltages, and we'll show the raw data that is from 0 to 1023 as 0 volt to 15.0 volt. Here we have our previous program which we have written in our previous session. Now we'll modify this program to convert the 10-bit ADC value into 8-bit ADC value, and we'll convert the raw data that is from 0 to 1023 into a meaningful parameter, that is battery voltages, from 0 to 15 volt. Here in this ADC read routine, we have stored the value of channel 0 into ADC channel 0, and we have stored the value of analog channel 1 into ADC channel 1. Now in variable assignments, we'll define two more variables, that is unsigned character ADC underscore channel 0 underscore 8 equals to 0, and we'll copy this variable from here, Control C, and we'll paste it here, Control V, and we'll change the variable, that is ADC channel 1 8-bit variable, and we'll use these variables in our ADC read routine. So here we'll use this variable, Control C, and we'll paste it here, Control V, equals to ADC channel 0, Control V, rotate right by 2. Similarly, we'll copy the variable for channel 1 also, Control C, and we'll paste it here, Control V, equals to ADC channel 1, Control C and Control V, rotate right 2 times. Now we have converted a 10-bit ADC result into 8-bit ADC result. Now I'll print this 8-bit result on LCD on line number 3 and 4. This time we'll not define the unit digit, 10 digit and 100 digit for ADC channel 08 and ADC channel 18. And here in print routine we'll perform 2 operations, that is to print the character on corresponding position as well as the calculation to get the value of the desired digit. So we'll write here, that is LCD character on row 3, column 10, and here we'll perform a calculation to get the value of 100th place digit. So we'll copy this variable from here, Control C, and we'll paste it here, Control V, and we'll divide this number by 100, and we'll also adjust the decimal place, that is %10, and now we'll add the constant, that is 48, to convert this number into equivalent ASCII. So here we are performing 4 operations in a single command, that is we are printing a digit on LCD display on a particular place. We are also performing a calculation to get the digit of 100th place position, and here we are adjusting the decimal place, and here we are converting this number into equivalent ASCII. Now I'll copy this line, Control C, and we'll paste it here, Control V. Now we'll change the position of the 10th place digit on column 11. Now we'll divide the number, that is ADC channel 08 by 10. Now here we'll paste the above line once again, Control V, and we'll print the unit place digit on 12th column. And here division is not required, so we'll delete these brackets. Now I'll perform the same operation to convert the result of ADC channel 1 to 8-bit. We'll copy these 3 lines from here, Control C, and we'll copy these lines here, Control V. Now we'll change the row number, that is 4, and here we'll change the variable also, that is ADC channel 8-bit 1. Here we'll also assign 2 more text messages, that is character text 3, equals to, that is ADC 8 channel 0 equals to we'll copy this assignment from here, Control C, and we'll paste it here, Control V, and we'll change this number to 4, and we'll also change this number to 1. Now we'll print text 3 and text 4 on LCD display. So we'll copy these lines from here, Control C, and we'll paste it here, Control V, and we'll change the row and columns, that is 3 and 4, and we'll also change the text label, that is text 3 and text 4. Now we'll compile our program and we'll observe the result on our prototype. Here we can see there is no error in our program. Now we'll download the hex file to the microcontroller and we'll observe the result on our prototype. First I'll connect PicKit3 programmer with prototype. And now we'll start PicKit3 programmer software. We'll go to the file, import hex, and here we have file ADC read. OK, write. Now we'll power up the prototype and we'll observe the result of our program. Here we can observe the problem in our display. Now we'll rectify this problem in our program. Here we can see in our program we have the same row for text 3. So we'll change this number, that is 3, and we'll also change the row number for text 4. OK, now I'll compile our program once again. We'll go to the file, import hex, ADC read. OK, write. Now once again we'll power up the prototype and we'll observe the result of our program. Now we can check the previous display problem is removed, and now we change the voltages from variable resistor 1. Here we can check the value is changing. When the 10-bit ADC channel 0 will go to the 1023, then 8-bit channel 0 will go to 255. Here we can check the 10-bit ADC value of channel 0 is 1023 and 8-bit value of ADC channel 0 is 255. Now we'll observe the result of ADC channel 1. And here we can check the result of our program. Now I'll modify this program to convert this raw data, that is 1023, to a meaningful parameter, that is 0 to 15 volt DC. Here we can find we are printing text 1 on LCD, and we have occupied 4 places, that is 1000 place, 100 place, 10 place and unit place. And from print routine we can see that we are printing unit place digit on 13th column. So we have 7 places to print any other message. So we'll write the converted data for voltages on these 7 places. So we'll write xx.x volts. So in this case we'll print the letter V on 20th column of LCD display, decimal place digit of the voltages at column 19 and decimal at place 18, and 2 significant digit of the voltages, that is unit place and 10 place, on column 17 and 16. Now I'll perform some calculations to convert the raw data into voltages, and we'll also modify the print routine, and here we'll assign another variable, that is unsigned character bat volt, that is battery voltages, equals to 0. Now we'll use this variable in calculation routine, Control C, and here we'll write Control V equals to ADC channel 0, Control C, Control V divided by 68.2. It will give us the result 15 if the value of ADC channel 0 will be 1023. Now I'll print the result of this calculation on LCD on row 1. So here we'll modify this print routine. We'll copy these 3 lines from here, Control C, and we'll paste it here, Control V, and we'll modify the rows and columns and variable accordingly. So here we'll change row 1 and column 16, 17 and 19, because we have to print a decimal point on column 18. And here we'll also change the variable, that is battery voltages, Control C, and we'll paste it here, Control V, and on column 18 we'll print a decimal point. So here we'll write LCD out, row 1, column 18, and a decimal point as text. And on column 20 we'll print the letter V. So I'll copy this line from here, Control C, and I'll paste it here, Control V, and I'll change the column, that is 20, and here I'll print the letter, that is V. Before compiling this program, we'll modify our assignments. Here we have written these letters, so first we'll remove these letters from here. Here we can observe that we have divided this variable, that is ADC channel 0, by 68.2. So we'll get the result in battery voltage variable, which will give us the number 15 if the value of ADC channel 0 will be equals to 1023, and if we'll divide this number, that is 1023, by 68.2, so we'll get the result 15. And if we'll print this number, that is 15, with the decimal point, we'll get the result, that is 01.5. But to display the result, that is 15.0, we have to divide the variable, that is ADC channel 0, by 6.82. So we'll get the result, that is 150. And if we'll print this number, that is 150, with the decimal point, then we'll have 15.0 at our LCD display. So we'll replace this number, that is 68.2, by 6.82. Now here we will replace this number, that is 68.2, by 6.82. And now we'll compile the program and we'll observe the result on our prototype. Here we can check we are getting the battery voltages, that is 0.0 volt. Now we'll change these voltages with the help of variable resistor. Here we can check voltages are changing. As the value of ADC channel 0 is 62, so we are getting 0.9 volt. And if the value of ADC channel 0 will be 1023, so we'll get the voltages, that is 15.0. Here we can check if the value of ADC channel 0 is 1023 and the 8-bit value of this channel is 255, and here we are getting the voltages, that is 14.9, which is equals to 15 volt. In this session we have learned that how to convert a 10-bit ADC value into 8-bit ADC value, and how to convert this raw data into a meaningful parameter, that is voltage of a battery. Here we can see that we have converted this raw data, that is 1023, into battery voltages, and we are getting the voltage of a battery, that is 15 volt, if the raw data is 1023.